Okay, in this video we're going to be talking about the Unit 2 pretest quiz. Um, Based off of your results, I'm going to go through some of this pretty quickly, and then I'm going to spend a little more time on stuff that a lot of mistakes were made. So let's go and get started. All right, first one, question number one. If you remember, you are to take all of the information that is right here and put it into the chart. I went ahead and did that before I started the video. There was 18 total options. All right, that's going to help us out. Now, question number one, find the probability that John will take a class during second period. Now, second period, as you can see, out of the 18 options, there's 3 of them. So my answer is going to be 3 out of 18, but reduces down to 1/6. All right, most folks got that one. Now, this is where things got a little more challenging, and that is question number 2. What a lot of folks did, they said that their answer was 2 out of 18, which meant it was 1/9. All right. Now, the only way that would be true, and we didn't really talk about this a little bit, so this is kind of a, okay, if you missed it, that's all right. And that is if this last part was not in there. So if this the given means what your total changes to. So it says the given that the class is in the morning. So you're no longer doing all of your options, okay? You are only doing, and let me get rid of this right here. We don't need that anymore. You're only focusing on the given, which is the morning. All right, so it's only going to be out of the morning. So if you do the math, 1, 2, 3, 4, 5, 6, 7, 8, there's a total of 8 possibilities. So let's get rid of that. So what is the probability John will have Radford's class? There's only one class that Radford teaches in the morning. So you would say this is 1 out of 8. All right. Now, that was kind of tricky. Not everyone got it. Some folks did get it. But just as a reminder, just keep that in mind. If there's a given, if that means it narrows it down a little bit. All right, so this question right here, if the spinner has, on the right, has been divided into 5 equals, okay. So if a player spins a blue and rolls an even number, all right, so the probability of spinning a blue, most folks will get a blue is going to be 1 out of 5. We get that. All right, 1 out of 5. If the player, oh, I'm sorry, if it rolls an even number, now if you remember, an even number on the die is a 2, a 4, or a 6. Okay, so that would mean the probability of that happening would be 1/2. A lot of folks got that, but they had no idea what to do with these two fractions. Now remember, folks, this is a compound event. And I said on day one, a compound event means you are going to be multiplying your fractions. All right, so 2 things have got to happen. You got to spin it, and you got to roll a even number. So when you take this and multiply it, you get a 1/10 possibility, 1 out of 10. All right. Now this right here, this tree diagram. Now there's going to be some questions that you need to use the entire tree diagram, and there's going to be some where you're not going to use the entire diagram. So let me zoom out a little bit so we can fit all. All right. So how many total options are there, guys? There's no reason at this point why you're missing this. All right. The options really on a tree diagram is the very last group, the last expansion here. 1, 2, 3, 4, 5, 6, 7, 8. There's 8 total branches, which means there's going to be 8 total options. In fact, I'll make that a little bigger. There's going to be 8 total options. All right. Now, what is the probability that someone will take their own car to an average restaurant and leave a big tip? All right. Now, this is something that we're going to need to use the entire tree for. All right. So let me get my highlighter here. Highlighter, let's see. Well, probably someone use their own car. All right. I'm going to highlight that. Leave go to an average restaurant. There you go. And then lastly, leave a big tip for the waiter. Notice you're using the entire tree, and you got to the very last. All right, so this is a 1 out of 8 situation. All right? So this is a 1 out of 8 probability. Now, if 300 couples go to homecoming, how many couples will take a limo? All right. Now, this is an instance where you're not using the entire tree here. You're only using half of it. In fact, you're using a third of it actually. We don't care anything about all of this. All it is a limo and take your own car. There's two possibilities, so that means there's a 50-50 chance. So a 50-50 chance would be 50 times 300 people, 300 couples that is. So your answer would end up being 150. All right. If you miss these, I'm not necessarily too worried about it because it's just easy fixes. All right. Now, question number 7. Again, before we start working on this, a couple things you need to understand, and that is this. What goes in here are the people. All right. The people. Oops. Let's try that again. The people. All right. That's what goes in there. All right. Not the area, not the percentage. Let me do it this way so it fit. All right. So it's only the people, not the area, not the percentage. Okay. That's what your final answer is going to look like. Now, not only that, using my highlighter here, remember that this number, this number, this number, and this number all equal 700 because 700 people start the problem. Okay? Now, we've done this several times, so you should know how to draw it. So 30% said pizza. Now, I'm going to use yellow. Some of you guys are not highlighting and you're not shading and you're just trying to remember how everything goes, and it's not working too well for you. All right, so all this is hamburger. Pizza. Hamburger, 60% right here. There you go. I'm going to use, what color am I going to use? I'll just use blue. All right. Shade all that right there. Now, the reason I'm shading is because I know what color works with what. All right, so this right here, this is going to be hamburger only. Nothing's in here. This is going to be neither. Nothing right here. This is going to be both. And this right here is going to be pizza only. Okay? Now, let's go ahead and get our dimensions. Our dimensions, remember, we're going to use the scale as our dimensions. So this will be, let's see, the height of our both here, that is 30. This right here is 70, which the opposite side is always going to be the same, 30. Right there. The bases, this ends up being 60. This ends up being 40. That's a 40. This is 60. And this right here is a 40. Running with my mouse here. All right. So now that I have all of my dimensions, I'm going to go ahead and multiply to get my areas. So the area, I'll just do this in black here. All right, so that's going to be 4,200. This is going to be 2,800. This is going to be 1,800. And lastly, pizza only, this is going to be, let's see, 1,200. All right, now, here's the thing, guys. Off to the side, I told y'all like, for example, both. The both section, take 1,800, and then divide that by 10,000. Now, if you really want to keep things simple, watch this. See the 1,800? Just erase the back two zeros here, and it's going to be 18%. It always works out that way. All right. So, like hamburger only, just erase 0.42. See, the neither section is 2,800. Just erase the double zeros in the back, and then it's going to be 28% or 0.28. And then lastly, this will be 12. All right, so that's a little step that you can do to kind of save some time. Now, remember, all you're going to do now is, let me get rid of this little arrow here. All you're going to do now, excuse me, is you're going to take each percentage and multiply it by the 700. All right, so that means for the both section, I'm going to take 0.18. I'm going to multiply it by 700, and I'm going to plug that right there. All right, I'm going to do the same thing for hamburger only. Hamburger only. Multiply it by 700, and then plug it right there, because that's hamburger only. And I'm going to do the same thing for pizza only as well as neither. So when you do the math, And again, most folks are getting this, but there's still some that are having trouble. 84, 126, 294 people, and then lastly, the neither section is 196. All right, all these three add up to 700. Okay, that's it, and you're done. All right, next one. Okay, we have a tree here, and I think I can zoom in just a little bit now. Let's see. Okay, that works. All right, so what is probability? Now remember, with this tree, you're either going to use all of it, some of it. You know, you're not going to. You may not use every bit on this tree every time. So let's see. Let's read this. And so we have. I think we need my highlighter. What is probability of someone choosing A for their first choice and then E as their second choice? All right, so I always start right here. A is 10%, E is 20%. So I'm just going to multiply these two branches together. Oh, that's the bell. I'm doing this during my lunch, so the bells are going to be a little crazy today. All right, so I'm going to take 10%. Actually, 10% is 0.10. I'm going to times it by 0.20, and I end up with 0.02. But when I change the decimal, it'll be 2%. All right. If 1,200 people were involved with this tree, how many would choose B as their first choice? All right, so this is an example of not using the entire tree. All right, so let me just do a couple things. I'm going to go ahead and cross out everything back here because I don't need it. All I need is the first expansion on the tree. Choose B. All right, so choose B, that is 60%. So very simply, I'm just going to take 60%, which is 0.60. I'm going to times that by the number of people, which is 1,200. And when I do the math, I get 720 people. That's it. For question number 10, it says, if 2,000 people were involved with this tree, how many people would choose C and then D? Okay, we're going to have to use the whole thing now. All right, so let me bring the whole thing back to play here. Now, this question 10 is very similar to question 8. You're going to be dealing with multiple branches, and you're going to be multiplying. All right, so choosing C, that's 30% chance, and then choosing D, which is 60% chance. All right, so off to the side here, that is a 30% chance, which is 0.30, times 60%, which is that. I believe that's going to be 0.18. And then I want to take 0.18 and times it by 2,000 to 1,000, and my answer ends up being 360 people. Okay, remember, find your percentage, then times it by the number of people. All right, so in this question here, create a Venn diagram. Okay, so 30 people said yes. All right, so 30 people said yes. Let's see. 30 people. Just right with my mouse here. 35 said neither, which is right here, 35. 25 said both. Now, 175 people voted. Remember, whatever number goes here, 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 and there will equal 175. Now, 30 people said yes. 25 said both, but 25 makes up part of that 30, which means the difference will be 5. Now, once you know all of this information here, just add and then subtract from 175. So when you do that, you end up with 110. All right. Now, what is the percentage that people did not vote for B? All right. So we are going to do a division problem, and that is did not vote B, and I'm going to divide that by the total, which is 175. So the people that did not vote for B, let's see here. The people that did not vote for B, let's see if I can just circle it here. This 5 did not vote for B. This 35 did not vote for B. So that's a grand total of 40. So it's going to be 40 divided by the total, which is 175. So when you do the math, you 23% rounded. Okay, moving on. Okay, so Amanda has injured her leg, may not be able to play with basketball. Okay, so first off, what we got to do is we got to read this and we got to figure out what are all of her possibilities. So if she can play, oh, there's the bell again. All right, so if she can play, that's 1. if she is not able to play. There's two. So there's my two options. So my two options are right there. With two options, I know I'm going to be dealing with 4 blanks because I have to make 2 pairs. Now this represents, this represents if she plays. This represents if she does not play. All right, so let's see if we can pull some information here. All right, so all right, there's a 50% chance. So 50% chance if she plays, her team will score 68 points, which means there's a 50% chance that she doesn't play, which means her team will score 54 points. All right, so if you remember, I'm going to multiply this and then add it to this pair after I multiply it. So when you do the math, and you do this in your calculator all at once, you get 61 points. All right. For this one here, find the missing values of the tree diagram. Now, remember, folks, that just because I started with W does not mean you can solve for W right then and there. Okay, it's just, that's the first blank that I just made. Remember what all equals 100%. This equals 1, that equals 1, that equals 1, this whole equals 1, and then also, some people might have forgotten, everything on this side equals 1. So everything that's highlighted equals 1. So let's go and do the easy stuff. The easy stuff, starting with this, that would be 0.72. That's easy. Z would be 0.37. All right, there we go. Now let's start solving for stuff here. The first thing I want to solve for, and there's not a blank for it, but I got to solve for it. I'm going to solve for where I'm going to be creative for a second. Let's be creative. There we go. Smiley face. That's what I'm going to solve for first. All right. Now, looking at our smiley face, if I go down the smiley face road here, and then if I times it by 0.37, that is what I get. All right, so in order to reverse it, I'm going to have to divide. So I'm going to divide 0.0703. I'm going to divide that by 0.37. And when I do the math, I get 0.19. So my smiley is going to be 0.19. All right, we'll put that right there. And let's see, I'm going to move Mr. Smiley right here. What else do I want to solve for? Oh, I can go ahead and solve for W. So I'm going to put my smiley right there. So solving for W, again, using my highlighter, 0.19 times 0.63 will give me W. So I'm just going to multiply these two together. And you can pretty much do that on your own. Let me move Mr. Smiley for a second. W equals 0.1197. All right. All right. What else are we going to solve for? Let me move Mr. Smiley here. All right. There we go. I'm going to put them right there. We're going to solve for that one. Now for my visual learners, I'm going to take whatever Mr. Smiley is. I'm going to times it by 0.28 to get this. So I'm going to work backwards. So working backwards would be 0.0532. I'm going to divide that by 0.28, and I'm going to get 0.19 again. All right, so that means that's going to be 0.19. Let me move this with Mr. Smiley down to the x. There we go. Now remember that this x, 0.19, x, and 19 all equal 1 whole. So a simple subtraction problem from 1 will give it to me, and so that's going to be 0.62. All right, what else do I need? Oh, got to solve for y. All right, now solving for y very simply. Now that I have all this information solved, I can easily go, again for my visual learners, 0.19 times 0.72 will give me what y is. And that's going to be my final answer that I'm looking for, that is. And I believe the answer for y is going to be, let's see, where is it? 0.1368. Make it a little bigger. So 0.1368, Mr. Smiley, I don't think we need you anymore. And that's it. Move you up there. There's your answers. All right, so just take your answers from the tree. Make sure you put them on your paper. All right, here we go. This guy. All right, now, based upon what I've seen, most of you guys understand the fact that the number of rows represents the number of the first expansion, 1, 2, and 3. Okay, so let me see if I can zoom out for a second. All right, so I'm going to go ahead and make 3 rows. Try to space it out the best I can. Okay, now I'm going to kind of speed up on a couple things because there's some stuff that you guys know how to do. The first thing you know how to do that I've seen, and that is the third trail. If you notice the third trail, it only has one branch, or one fork, that is. So we're going to go ahead and do that. We're going to call this will be the pumpkin, and this will be a no pumpkin. All right. Even the top one, most folks were getting right. All right, so let's go ahead and focus on the top one for a second. All right, so the top one here, walking, 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 boom, there's my first fork. So that means I'm going to half it, like so. If I keep walking, walk, 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 boom, there's a pumpkin. Again, it wasn't this row that killed people, it was the middle one. Now finishing out, walk, 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 boom, uh-oh, another fork. So I'm going to half my half. And then that forks to either a no pumpkin, pumpkin situation. So let me go ahead and do pumpkin, no pumpkin, pumpkin, no pumpkin. Now, it's the second row. That's where our issues lie, okay? So here we go. Starting right here, walking, 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 boom. There's our very first fork. All right, so I'm going to go right there. That actually worked out. Look at that all lined up. Awesome. If I was to continue, let's just say I was going to continue on the second one. I just want to go do this way. Boom, there's another fork. All right. So let me go ahead and half that. And notice it goes no pumpkin, pumpkin. All right. So that was the least confusing side of it. So no pumpkin, no pumpkin, pumpkin. So that was the least confusing side. All right. So let's go back because we did not finish out. There's our fork. Okay. So we've got to use, again, for my visual learners, we got to finish out this section right there on our area model. Okay. So walk, 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 boom. Oh, there we go. There's a fork. So let's cut it in half. I hope that all line up. My OCD kicks in sometimes. And it's not moving. There we go. All right. Now, if I was to continue walking, walk, 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 boom, I run right into a pumpkin. All right. So that's that part. Now, the last thing I need to do, and that is, let me highlight back, is I need to finish out this fork here. So I start walking, walk, 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 boom, another fork. So that means I'm going to half my half my half. I don't even know if that makes sense. We're going to go with it though. There and there. All right, so that's a pumpkin, no pumpkin situation. All right, so pumpkin, no pumpkin. All right, pretty simple. Now, at this point, we are now going to throw some dimensions on here. So we're going to go ahead and do the 12, 2. All right, so this is going to be 2. This is going to be 2. This is going to be 2. All right, I'm going to go ahead and use red. We're going to do this being 12, so that's a 6. That's a 6. That's a 3. That's a 3. This is a 6. This will be a 3. This will be a 3. This will be a 3. This will be a 1.5. Remember, all this is drawn to scale. Anything that looks like it's a half is a half. All right. So when you start doing all the areas, guys, anything that looks the same as it, like for example, this pumpkin down here, this is a 12, which means this will be a 12 because it's the exact same size. This right here will be a 12, okay? This no pumpkin right here, that's a 6. That'll be a 6 because it's all the same size. 6, 6, 6. And then lastly, that's a 3, and that's a 3. All right? Now, what is probability of winning a pumpkin? Just add all of your pumpkin pieces. Let's see, right there, right there, right there, right there, right there, right there. All right? Add all those pieces up. I believe it ends up being, let's see, what does it end up being? I think it adds up to be 45. Let me check though. Let's say it's 18 plus 15 plus 12. Yep, 45 divided by the total area of the entire model, which is 72, and the probability ends up being 63%. Now, if 500 people walked to the poll, how many would end up with a pumpkin? Now, guys, you already know 63 will get a pumpkin. So 63% will get a pumpkin. All right. There were 500 people who walked. So very simply, I'm just going to take 63% and I'm going to times it by 500. So when I do the math, it ends up being 315 people. All right. Moving on. All right, next question. We have the candy cane question. So again, you can kind of decide what you want to do. I think we're kind of beyond the entry stuff. So let's see, that'll be a 2, that'll be a 2, that'll be a 2, that'll be a 2, which makes that a 2, which makes that a 2, which that makes a 4. Now, how wide do you want to make it? I don't know. We'll just do 12 again, which means that'll be a 6, that'll be a 3, that'll be a 3, that'll be a 6, that'll be a 3, that'll be a 1.5, that'll be a 1.5. All right. So once you, again, all this is drawn to scale. So once you figure out some areas, you can pretty much make everything. So like, for example, this guy down here, that's 12. That'll be a 12, which makes that a 6. A lot of these numbers, that's a 6. It looks like a G. That's a 6. 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 This is 4 of them, so that'll be 24. That'll be a 3 because it's half of a 6. 3, half of 3. All right. And at this point, I mean, it's very similar to what we just did. So we're going to take the number of candy canes and divide that by the total number, the total area, which is 128. So because of time, I'm almost at the 30-minute mark. I need to speed up a little bit. That, and that. Add all that up, put it over 220 or 128, and my answer ends up being 44%. Now, what throws people off, and that is 44% wins, which means that's an arrow. 56% loser. All right. So in question number 17, if 500 people play the game, how many will not win a candy cane? Not win is 56%. We are going to times that by 500 people, and our answer ends up being 280. All right. And I could zoom in now. All right, so there are 12 markers in a box. Blah, blah, blah. All right, here we go. The probability of choosing a blue. That's easy. 6 over 12. Easy. All right, but here's the thing. You're not replacing it. So choosing another blue, there are now 5 possibilities out of 11. And again, you're not replacing it, so that means choosing an orange, it'll be 1 out of 10. So remember, you're going to take all of these, and you are going to multiply. And when you do that, you get a big old number. I think it's like, let's see, that'll be 30 divided by 120. I don't know if that's right. Nope, sorry, that was way off. 1320, but when you reduce it, it ends up being an answer of 1 out of 44. All right. All right, there's a prize drawn from home electronics. Tickets are $10. There's a total of 250. All right, so the two prizes are a new computer worth this, high definition. All right, so count the possibilities. We have a new computer, high definition TV, or you could be a big loser. That will be 3 possibilities. All right, so 3 possibilities means 6 blanks. Blank, 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 blank. I don't know why I wrote them so small, but we did. All right, so this represents the computer. This represents the TV. This represents if you're a big loser. Now, you should know at this point to subtract $10 from everything that is being purchased. So that's $290. The TV will be worth $490. And if you're a big loser, you're negative $10. Okay? Next is the probability. All right, so the probability would be 1 ticket wins a computer, 1 out of 250. The TV, 1 out of 250. And then lastly, there are going to be 248 losers out of 250. So you are going to multiply all that together. And when you do that, you should get an answer of negative $6.80. All right. And lastly, for the area model, I already gave you some dimensions here, so you just break it up. That's 5, that's 5, that's 5. Now notice that the whole thing is going to be 24, so that means everything is going to be 3. 3, 3, 3, 3. Writing with my mouse is not very easy. All right, so go ahead and find the areas, so multiply. So when I multiply the areas, I'll just do some purple here. That will be a 60. Remember, this is drawn to scale. 60. So anything that looks half will be half. All right. And all these are going to be 15. 15. And then, as I'm writing this, I'm going to go, we got to find the probability of people who will not win. So I'm going to add everybody that has a no attached to it. So let's see. No, 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 no. I want to add all those up. Oh, forgot one. Oh, there it is. And I'm going to, when I add them all up, it ends up being 210. And I'm going to divide that by the model area, which is 360. When I do the math, I get rounded 58%. Now the question is not what the percentage is, how many people will. So I'm going to take 58% and I'm going to times it by the number of people that played the game, and my answer will be 290 people, rounded. All right? Now, again, you might have made a bad grade, but that doesn't mean you don't know it. That just means you're probably overlooking something. So don't get stressed out, and you got this. Let me know if you have any questions. Goodbye.